Okay. What we're going to talk about today is we're going to talk about linearization. Linearization. Now, what is linearization? That's one of the key things. Well, linearization is simply using tangent lines to approximate values, approximate values. All right. Values of a function, pretty much, or whatever type of equation you have. All right. And to do that, the key thing is the first and easiest way to use linearization is to approximate a value of a function around a centered point or the point of tangency. So what do I have here? I have a little example. Is what I want to do is I want to approximate what is the value of, I don't know, let me give it a point. Let's say I want to find out what is f of, let's say 2.01, all right, 2.01. I want to figure out what is the value of 2.01. Now, traditionally, or what we would do is you have to take and put in 2.01 into this function. And you could do this, and you probably would need your calculator because this can be rather complex because we have decimals and fractions and whatnot. But I want to use this to approximate 2.01. Well, when you do that, we'll take out our calculator and we'll find out what that value is. All right. So if I recall, I'll just make this a little smaller. Oops, hello. All right. Now I'll move this over here. And what we have is x cubed minus 2x plus 3. Okay. Sorry about that. All right. So x cubed, all right, plus, make sure you get down here, plus, and what do we got? Oh, sorry, minus 2x plus 3, okay, minus 2x plus 3, all right. Now, if I want to find this value, what I could do is I could go to my table. I'm going to do that. I'm going to go to table, and I have input values, and I'm going to put in 2.01. And what we get is an answer of 7.1006. All right, 7.1006. So that is what the value is going to be, 7.1006. Maybe that's rounded, but that is what the approximated value, or actually the actual value, would be if I plug that in. Now, for mathematicians back in the day, they didn't have a graphing calculator, and doing these calculations could be very strenuous and taxing and take a long time. So to find a fast and efficient way, what they use is known as linearization. Linearization essentially is where you're going to use a tangent line to help approximate a value of a function. What we're going to do is we're going to use the concept of linearization, in which, if I would go back to this graph right here, I'm going to graph this now. All right. Oops, I'm going to go zoom 6. All right. Zoom 6. I can quit. I'm sorry about that. Zoom 6, and let's graph this. And we're going to graph this, and you can see that here comes my graph. There it is. And here, right here at 2. Now, here at 2, we can see that it's going to be, or 2.01, it's going to be somewhere right around here. So if I would take this, you know, you're going to be right around here. Now, what we're going to do here is actually, and let me actually take this down here. Okay, yeah, that's cool. Oops, hello. This is not going very well. I apologize. All right, but what we have right here is we're going to be taking this, all right, graph, and I want to figure out what is the value here at 2.01. So 2.01 is roughly about right there, okay? And it's very close to 2, where you can see it's 2 is right at 7. If I would draw a horizontal, or actually a tangent line, okay, and I'm going to draw like a just line segment. And if I would try to draw a tangent line like here, hopefully you'll notice that this tangent line, the values that are near the point of tangency are around 2.01. So I'm going to pick the closest value next to 2.01, which would be 2. Right? That's why you see up here, I'm going to pick that. At 2, you can see that the values around 2, all right, those values on the line and the actual function itself are very, very close. And that is one of the things why we're using linearization. Is linearization, if you stick close to the point of tangency and all the values around 2 are very close to 2, the tangent line, which is right here, this black line, and the function, those values will be very close. The farther you get away from that point of tangency, the less accurate that approximation or those values will be between the function itself and the line. So just to illustrate this fact, what we're going to do is I'm going to actually solve and approximate this using linearization, which is using a tangent line. So I'm going to find this tangent line. And we're going to center this around a value close to 2.01, and that value is going to equal 2. So right here, I'm going to go and solve this. Now, to find the equation of a tangent line, we need a point and a slope. So I'm going to use L of x, which means, all right, tangent line. And we need to figure out what is the slope of this line. Now, the slope, hopefully you recall, is going to be f prime of 2. And then we're going to take that and we're going to finish our line x minus x1, which is going to be 2. And then we're going to plug in f of 2 into there, find what that value is. When you go through, what we're going to do is we're going to find this derivative first. I'm going to get a number here. So if I find f prime is going to equal 3x squared minus 2. I plug in 2 into there. We have 4, 12, 10. I believe it's 10. So we have 10 times x minus 2. And then we'll have this right here, f of 2. F of 2, you can plug the 2 in there, but you probably can see right here, it appears to be 7. 1, 2, 3, 4, 5, 6, 7. Yep, right about there. Okay, somewhere right around there. All right, and that's going to equal 7. Okay, now from here, I'm going to use this tangent line around 2 to help me approximate what actually the value of 2.01 will be. So to find the approximated value of 2.01, I'm going to actually not plug this into this complicated function. I'm going to actually plug it into this tangent line function, all right, which is very close to the actual values of the function around 2. And when we do that, we're going to have 10 times 2.01 minus 2, and we're going to have plus 7. If we go through here, we can realize that, okay, what it's going to be? Well, we have 0.01 times 10 plus 7, and what we have then is going to be 7.1. Now, if you look at this approximated value, all right, you realize that this approximated value of 2.01 using a tangent line is very close to the actual answer itself. And actually, if we want to take a differential, we could actually take the actual value at 2.01, all right, and subtract that from the approximated value and find out a differential of being, what do we have, 0.0006, all right, and that would be our value. So this is how close it would be up to the 10th, 100th, 10,000th place. We're going to be right on. And so that's what linearization is. Linearization is using a tangent line, all right, using a tangent line to approximate a value of a function, knowing that a tangent line is very, very close to the values around its center point. All right, well, let's try another one. All right, there we go. Let's try this one right here. What we're going to do is we're going to find the linearization of L of x of f of x at x equaling a. So we have f of x equals the square root of x squared plus 9 at x equaling -4. All right, and we want to figure out what is the approximation of L of a at 0.1, so a of 0.1. So essentially, I want to find what is, all right, I want to approximate what is f of, plug in -4, -4 is our a value, all right, plus 0.1. And so essentially, I'm looking for what is -3.9, all right, 3.9. Now to find this out, I could actually plug that into my actual function, all right, which we could do. But I'm going to use the tangent line approximation. So I'm going to take and find out the approximate value. I'm going to use L of, all right, find out what L of -3.9 is going to be. And I'm going to center that around a value close to -3.9, which is going to be our a value, which is -4. All right, so let's do that. Now to do that, we're going to do the same thing. So I have to find L of x. L of x, once again, is our tangent line. So remember, we're going to find a tangent line. A tangent line. All right. So we need our slope. Our slope's going to be f prime. So I'll find f prime. It's going to be 1/2 x squared plus 9 to the -1/2 power times the derivative of the inside using the chain rule. We got 2x. All right. Simplify this. This, and what do we got here? We're going to have x on top, and on the bottom, we're going to have the square root of x squared plus 9. All right, so let's plug in -4 into there. we have -4 plugged in there, so we know that f prime of -4, which will give us our slope, f prime of -4, prime of -4. And then we'll have x minus, actually plus 4. And then if we actually plug in and add plus f of -4 to finish off our tangent line. Okay, so let's do that. We have this, we plug our -4 into here. We have -4 over -4 squared, which is 16 plus 9 with 25. So 25 is going to give us -4 fifths. All right, 24 fifths. We're going to have that x plus 4. And then we're going to plug in -4 fifths into f. -4 squared is 16, plus 9 is 25, square root of 25 is 5. We're going to add plus 5 here. All right, so that is what our line L of x is going to equal. Let's use that now to approximate what our actual value is going to be. So we have -4 fifths. I'm going to take -3.9 plus 4, and then I'm going to add 5. That's going to give me 0.1. Take that, -4 fifths plus 5. Do a little math here. We got 1/10 times 4 fifths, negative, and then a plus 5. I'm going to cancel out some things. It's going to turn to 2. That's going to turn to 5. So we have -5/25. And I'm going to change this so I have a common denominator. And what we have is 125 over 25. Because 25 times 5 is 125, I believe. And then we take that, and what we have is 120 over 25. We can simplify that, or I'm going to just put 120 my calculator. All right, 120 divided by, what was that again? By 25. And what we have is 4.8. 4.8. All right, so that's approximately going to be 4.8. All right, and that's what our approximation is going to be. If you want to figure out what the actual value is, what we're going to do is we have to take and plug in that actual value into our calculator. So if I go over here, all right, and I plug in this actual function in here, and maybe I'll just plug it in and just go square root of, we'll go -3.9, and we're going to square that, and then we're going to add 9. I think I plugged it in correctly. And let's see what our final answer is. And our final answer is, oh, did I get this right? Oh, no, what did I do wrong? All right, thought it was going to be a little closer than that. All right, make sure we get it all right. Oops, square root of -3.9. Yep, -3.9 squared plus 9. Yeah, we have 4.92. 4.92. All right, so the actual value, all right, actual value is 4.92. All right, 3.9 is 4.92. And if we compare these two, all right, compare these two, not the best approximation, all right, and I'm just going to make sure I did all this right. All right, I'm going to use my calculator and just kind of, golly gee willikers. All right, move this over, -4 fifths. All right, -4 fifths. I apologize for all this, but once again, times 0.1. All right, and we got plus 5. And, oh, there we go. Oops, I did some math wrong or something around here. All right, we should add 4.92. I knew I had a sticky suspicion. 4.92. All right, 4.92, and what? Oh, 4.92036. Oh, okay. All right. All right, so you can see that these two different values, okay, right here and here are very, very close. So obviously I did something a little bit incorrect, all right, going through and solving this. So I apologize, somewhere my math went wrong, and for sure some of you out there are figuring it out as we speak, all right, and going through it. Oh, I see what I did. I can't multiply. This is 2 times 1, which is 2. All right, that'll do it every time. All right, so actually we have 2 right there. I see that. And then we have actually 23. Okay, so that makes a lot more sense. 92. All right, I apologize. Can't add. All right, but you can see that our two answers are very, very close in what they would be. And 5, 8, 4. And once again, this is up to the 10,000th place as we're going through and figuring this out. Okay, well, what did we just learn? Well, we learned that linearization is using tangent lines to approximate values of a function. All right, and we can do that if we want to find an approximated value with decimals or whatnot that are around a centered point. Okay, so that is what linearization is. It's using tangent lines to approximate values. There are many other examples in calculus where we can use this, and this is just the first introductory part of what you'll have to do. All right, hope this helps you out. Good luck and God bless in the rest of the problems.